expected. Okay, so the first slide is basically the introduction slide. We're going to look at what's happening with PFAS legislation in Europe, USA, and Canada. We'll also touch on what's happening in the UK, and Rob Grant later on will be talking about the water industry in this country. So can we move on the slide, please? Okay, this is a bit of housekeeping. We have no alarms to go off today, which is good, webinar. But the event will be recorded and made available in our Process Industry Division YouTube playlist. If you want a CPD certificate, we'll send it out. And any questions through the Q&A or the chat tabs that I mentioned earlier. We don't want any AI chatbots. We will switch them off if we see them. Okay, there's quite a bit in the internet this week about chatbots and how they can be used to cause problems later on. So we'll try and avoid them. So this is a little bit about who we are and what we do. We're IMechE, Institution of Mechanical Engineers, the Process Industries Division. I am the chair of the Food and Drink Engineering Committee, but basically we're in bulk materials, food and drink, oil and gas, pharma, upstream oil and gas, and water and wastewater. So we have divisions covering all of that. We're about 108,000 members in the IMechE, so we cover quite a lot of ground. Okay, next one, please. We are equity, diversity, and inclusion organization. No one is left out. I'll give you a couple of minutes to read it, or a couple of seconds to read it. Okay, so this is my bit. This is where I'm going to introduce you to the speakers. We're going to start off with Sandy Vandenbroek and Ralph Vogel, are going to be talking on the European, basically the international scene. Sandy is Environmental and Social Governance Director of the European Sealing Association, quite a major player in the sealing industry. And Ralph Vogel is Technical Director of the same organisation. They will be basically doing the main presentation for us. We then go on to Christian Gugert. Christian is from Angst & Pfister. Basically, they're seal manufacturers. They do a lot of work with PFAS, and in fact, what he's now doing is he's going to explain a new product they're bringing out, which basically would take the place of, we hope, of some of the PFAS materials. So that's be quite interesting to talk to. Then we have Rob Grant. He's a senior technical director and project director in the water consultancy team. He's also chair of the water and wastewater group in IMechE. So yeah, there's a lot of experience here and talk and give interesting talk on water and wastewater in the UK. Then we have John Morton, who's going to be involved in the panel at the end, answering questions. John is Portfolio Director of John Crane. I think most of you have probably heard of John Crane, a seals and couplings manufacturer. John's held several positions in engineering and other roles in John Crane. Okay, so he'd be a worthy person to talk. Finally, there's me. I'm chair of the Food and Drink Engineering Committee. I'm a retired brewery design engineer. Worked many places around the world, but I think it's enough of us. Let's get on and see the talk. So can I hand over, please, to Sandy? And Pam, could you?
Thank you, Martin, for the introduction. If it's okay with you, I will try to share my screen. If things goes well, you see the background.
Yeah, we got Sujo.
And got Sujo again. Okay, good afternoon, ladies and gentlemen. My name's Sandy Vandenbroek. I'm a mechanical engineer. I've been involved in the sealing technology for almost 40 years, trying to prevent leakages in the industry, all kinds of industry sectors, as well as trying to reduce the emissions into the atmosphere, into the environment. Today I'm actually representing, excuse me, the European Sealing Association. And today I would like to share a brief presentation on the PFAS restriction process in Europe and beyond, and its impact, its potential impact, especially on the sealing industry, which is of course interconnected with all industries. And now I'm trying to, okay, just to give you an overview of the content, who we are, what our aims are, an overview on the PFAS restriction process, the PFAS development, the PFAS in fluoropolymers, because they're all classified under the same category, the controversy and exemption arguments, industry impact and consequences, update on the today's PFAS restriction process, which is ongoing, very hot topic, and the next steps which will be taken by the European Sealing Association. So who are the ESA, European Sealing? We're not a space agency, we're the Sealing Association, and representing today 64 to be exact companies in Europe, including UK, of course. We also have two research organizations, IMechE in Germany and SETIM in France, doing tests, leakage tests, comparison tests. We were established in 1992 and registered in Germany and the UK. We're a non-profit organization. We don't sell, we don't buy anything. And we have 5 active product divisions. We've got the elastomer and plastic division. We've got the flange gasket division. We've got the mechanical seal division. We've got the braided packings division. We've got the expansion joint division. Okay, so what are the aims of the ESA? It's of course to harmonize of appropriate standards and relevant legislations. Of course, promoting and developing sealing technology with a focus, of course, on the safety, the efficiency, and the environmental protection. So the ESA actually operates as an international group on issues where an individual company may have limited influence, limited resources, activities in the relevant standards and relevant legislations. And as you know, there are many in Europe. And we're also in very good contact with the national organizations and of course with other associations worldwide. We are working together with Institute of Mechanical Engineers in UK, the British FAL, the Actuator Association, the Fluid Sealing Association in the United States, European Car Association, to name a few, but there are many more, especially now when we are focusing on the PFAS topic. So we also focused on training, education, of course, for newbies, young engineers as well. Okay, coming back to the topic of today, the restriction proposal have actually been initiated by 5 member states in Europe: the Netherlands, Denmark, Germany, Denmark, Sweden, and Norway. And actually, public consultation was initiated from March to September 2023. And of course, the the objective of those dossier submitters was to mitigate the environmental and health impacts of PFAS blanket ban for over 10,000 chemicals. So the scope was actually to ban all non-degradable PFAS substances, even on the manufacturing of PFAS-related products, and of course, placing on the market. I will discuss a bit more on the sector specifically assessed by the URAC and the SEAC in Europe, which are governed by the European Chemical Association. Out of this public consultation, more than 5,600 comments were received, and they were actually initiated by 4,400 companies. So this ECHA was overwhelmed by the number of comments. Out of that, a draft background has been prepared June 2025 with the based on the comments, a few thousand pages focused on all the industries. Unfortunately, sealing applications were not assessed by the Social Economic Assessment Committee due to a lack of time. So this is unfortunately what happened. So just an overview of the 14 specified sectors. They spend a lot of time on ski wax, but sealing applications, machinery applications, medical uses, which are very critical, very important, and of course today military applications, explosives, technical textiles, and all some wider industrial uses. So these on the right side were not assessed by SEAC. I will explain a bit more on the further restriction process. So what has been considered? So the 14 specific sectors, including the manufacturing of PFAS or fluoropolymers production. Okay, just to give you an overview, PFAS has been developed since the end of the 30s, and as explosive growth since the 50s, 60s, and 70s for numerous consumer and industrial products. One of them are the AFFF, the aqueous film foaming, or the firefighting foams, which can be traced all over Europe, all over the world, and they've caused a lot of concern, pollution, but I will explain a bit more. And then, of course, since the 70s, a variety of products has been introduced. And of course, since the year 2000, we developed the technique to determine, to measure the pollution in water, in the soil, in the air. So there are more techniques, but also to improve the production of PFAS. A bit more on PFAS and fluoropolymers, because there are, as mentioned, 10,000 different substances, and they're all classified as PFAS. However, there is a differentiation between these products. Why are they called PFAS, or some call them forever chemicals? Because these are synthetic chemicals, and they're known for the strong carbon fluorine bonds. And this strong bond on the radical actually creates very interesting properties in terms of high resistance to degradation, so high durability, water and oil repellents, good temperature, but also very good, very high chemical resistance and low friction. Just to give you an overview, there are the PFAS as classified. You have the non-polymers on the left side, and you have the polymers on the right side. The left ones are the ones which are causing the environmental and health problems and should be taken care of. And as you see, some of our examples, the PFOS and the PFOAs, have already been banned, restricted in a lot of countries. but they have been used as surfactants, polymerization aids, and we need the raw materials, and polymerization aids needs to be there to produce polymers. Of course, we are now focusing on non-fluorinated surfactants or polymerization aids. But if you look to the left side, the non-polymers are known for the low weight, small molecular sizes, and the polymers are actually known for the higher weight and much larger molecular chains, and are therefore have completely different properties because they're used for medical, surgical stents and so on, and they're non-toxic, non-bioaccumulative. But nevertheless, they are classified under the same category. And they are used, especially the PTFE, the EVPs, the PFAs, but also the perfluoroelastomers for O-rings, used in all kinds of industries. And they're under pressure right now. Okay, as mentioned already, used in a lot of applications. As you can see, petroleum chemical industry, the backbone of Europe, which is declining, unfortunately, since 2022. We have closed down 10% of the chemical industry with a loss of 20,000 jobs. So fluoropolymers, such as PTFE, are very crucial for the widely used in sealing applications. And as you know, sealing applications are used in all kinds of industry, not only related to chemical or medical, but also automotive, transport, nuclear, and also new evolving technologies. Okay, just an extraction from the background document where I actually focused. There are a few thousand pages, and of course we are focusing on sealing applications in Europe, and it is estimated, and I took the literally the word estimation, that 22,725 tons a year of polymeric PFAS are used in sealing applications. 1.5 of these volumes of polymeric is used in sealing applications during the service life are emitted into the atmosphere. So whether it is in the soil or into the air, you can say 1.5 is low, but it represents 341 tons a year, which is pretty high, extremely high to our attention. And we have actually, as a association, we've questioned the figure of 341 tons, because most sealing applications, whether we're talking gasket, O-rings, mechanical seals, they are pressure concealed. So they're actually into a kind of a pressure envelope. So the idea, as I mentioned initially while introducing myself, is actually to reduce the leakage. And actually today we're not talking about leakages, we're talking about emissions, reducing emissions from the products which are produced into the environment. End of life, I will talk a bit later on that one. So there, okay, took some extractions. So the derogation, there is a kind of a derogation for sealing applications in industrial uses, which means 12 years of derogation, so 12 years of time to look for alternatives. So 13 and a half years before it gets entry into force. But then if you go down to another paragraph, you see restriction option 3. Just to inform you, restriction option 1 is a full ban of PFAS-related products. Restriction option 2 is actually a derogation, whether it is 6.5 years or 13.5 years. And restriction option 3 is an additional, continuation of the usage of PFAS-contained articles. And it's also mentioned that the fluoropolymers in sealing applications are considered. However, with the restriction to minimize emissions during production. So during the production of base materials, this is related to the PFAS manufacturing companies, and of course during the lifetime, which is of course very difficult, how to define the potential emissions during a lifetime of an O-ring of a seal. And it's mentioned that abrasion, especially for dynamic applications in mechanical seals or braided packings, there could be abrasion. So some of the products of the fluoropolymers could go into the environment, but once again, it's pressure concealed. So this is also very vague. But then it comes to the end of life, where they say restriction option 3 should have 95% of recycling fluoropolymers. I will come back on that one, which is of course very critical, because today 83% of fluoropolymers, 84% goes from waste to energy, which means incineration in specific plants. And there's been some studies going on. Okay, this is just an overview from the background document, the IMechE 15 report, where it is mentioned again that the sealing application in industrial users have a derogation proposed period for 13.5 years after entry into force. And then for spare parts, there seems to be a kind of a derogation, a time limit for 20 years after the last article was allowed to be placed into the market, or until the end of service life. So still a bit vague on how to move forward, but still a draft opinion, not decided yet. So what is the current situation of the SEAC draft opinion? So as mentioned, the 14 sectors to the left side will have sector specified or specific orientated questions. The ones which were not assessed by SEAC, including the sealing applications, they do have to reply to general questions identified in the background document. However, the questions which we already received are not referring to the background, they're referring to the draft opinion, which needs to be released by, in March. So we have to wait until the end of March. However, we don't want to wait. We are already preparing ourselves, for the simple reason we only have 60 days to for the public consultation. Stakeholders only have 60 days to reply, which means April, May. As you know, in Europe, we have some bank holidays, trying to enjoy ourselves, but we will not have the time for that. So that's why we are preparing ourselves. The consultation will be conducted as a survey, question answers, without the option for attachment or even links towards certain web pages or files. And on top of that, the replies will be limited between 500, 5,000 characters, depending on the type of questions. So the guidelines have been submitted, and we are working. We've already prepared a template with all the questions for the 14 sectors, as well as for the 8 additional ones, and how to reply to it, because it's very, very complex. Okay, so coming back to the potential restriction option 3, the fluoropolymers product group in Europe, representing different manufacturers, they have already started, for some years now, to reduce the non-polymeric PFAS emissions during the fluoropolymer manufacturing. They have created a technology platform sharing the best practices and also safe handling guides. And they're also working on certain objectives to reduce the amount of emissions during the production of of fluoropolymers, and they've actually achieved the targets for 2024, 2025, and they comply with the IMechE restriction report. The target for by the end of 2030 should be 0.003 into the air and 0.0006 into the water. So very, very critical standards for the production. So this is, of course, very restricted, but very necessary to protect the environment and to protect our health as well. They're all also working on the end of life recycling for fluoropolymers, and it was said that they would come up with a study end of last year, but actually the report is expected to be Q1 of this year. So there will be a webinar on the 19th of March. I will attend, and looking forward to see what can be done in terms of recycling. But right now, 84%, as mentioned, goes from waste to energy by means of incineration, 13% is landfilled, and 3% of fluoropolymers are recycled. Even if we have today, and I'm sure it exists, a way to recycle, the question is, would it be economically viable to recycle rather than just, incinerate them? And according to the Karlsruhe Institute of Technology, 99% of the residues after incineration are free from PFAS. Okay, another report which has been recently introduced by the European Parliament, and that's very important because at the end of the day, European Parliament will take the decision on the restriction procedure. And this has been introduced, or the study has been delegated by the Institute of Technical Research and Energy Committee. And they have focused on 6 fluoropolymers. As you can see, they're all representing 93% of fluoropolymers in Europe. Under options, restriction option 1 or 2, fluoropolymers will not automatically exempt from it. The substitution is often technically impossible for fluoropolymers in critical applications, because fluoropolymers are already used for critical applications for decades now, for the simple reason of their performance in high temperature, chemical inertness, long service life, and ultra-low contamination. They are focused on 3 sectors in order to speed up: the aerospace, defense, semiconductors, green energy, clean technologies. And of course, these industries, they rely on seals, on gasket, wiring, bearings, fuel systems. So all industries are interconnected, and the study concludes that application by application assessment is necessary. What would be the social economic impact, industrial impact? First year would cost 560 billion euros under a restriction option 1 or 2, annual recurring cost of 70 billion. And it would have an impact, of course, on 39,000 enterprises with a risk of 2.9 potential jobs. And then I'm not talking about the small, medium enterprises, which are, of course, exposed and affected. Okay, so the document actually concludes that fluoropolymers are essential for the European industrial competitiveness and strategic autonomy. Under the current EU PFAS proposal, substitution assumptions are often unrealistic. There have been a lot of tests for alternatives, but 80% are non-feasible. Timelines do not reflect, so the 13.5 years do not reflect safety or innovation realities, because it takes a lot of time, especially certain industries, the chemical industry, automotive, aerospace, before a product is approved, homologated, and tested, it can run up between 5 and 20 years. A blanket PFAS approach risks disproportionate harm and relative to the environmental benefit. So the study supports a more differentiated sector-specific regulatory approach for fluoropolymers within the PFAS restriction framework. It's at least some light in this long tunnel for fluoropolymers. So what's the timeline? So as you can see, we are somewhere in the middle. So 60 days consultation on SEAC draft opinion. So we are waiting to receive the final opinion before we can actually start the preparing ourselves. And then they expect to finalize before the end of this year. Then 2027, the opinion of IMechE will be communicated to the European Commission, and then the Commission will present a proposal to the REACH committee, and finally the Commission transmits its final proposal to the European Parliament. We expect entry into force would be around 2030, but this is tentative timeline. Okay, giving an update on France. As you know, France is a bit ahead of the 5 member states of the EU because they've actually implemented already since the beginning of this year some PFAS restrictions, especially on cosmetics, ski waxes, clothing, footwear related to waterproofing treatments. And so products made before that can be sold for up to 12 months under a transitional stock sell-through period. So from 2030, they will ban all textile products except for protective clothing and, of course, for emergency and military forces. And then they will implement a kind of a polluter pays fee with a PFAS discharge fee, depending on so will be implemented in this year and would be approximately 100 euros per 100 gram of PFAS discharged. How they will monitor, how they will measure, that's another debate. But anyway, France is approaching in a considered faster way than Europe. Regulatory framework for PFAS in the United Kingdom. So it's also under UK REACH because the UK standalone chemistry safety regime took effect after the Brexit. Health and Safety acts as the UK REACH authority, and certain PFAS has been registered. PFAS are identified as a priority group for future risk management actions, including potential restrictions, especially on the firefighting foams, because they're one of the main sources for the pollution, the PFAS pollution, the short molecular size pollution. And that's open for this consultation, still due for 2026. So multiple consultations and proposals are still underway, especially targeting specific uses like the firefighting foams, but not yet legally binding. The persistent organic pollutants POPs regulation, which is actually aligns with the Stockholm Convention, actually bans the PFH excess as well as the PFOA, which I mentioned, the PFOA and the PFOS, which are of course prohibited and causing the environmental and health problems. Okay, just going a bit further. Drinking water, I'm sure Rob will talk a bit more in detail on that one, because there seems to be also different legally binding limits between Scotland, England and Wales, if I'm not wrong, yes. So yeah, the drinking water standards for PFAS in England and Wales remain the guidance-based rather than statutory. So there is political and scientific pressure to adopt enforceable limits. Okay, the PFAS containing products sold in the UK must comply with general product safety requirements under the GPSR, which has been initiated in 2005 in Great Britain. It doesn't ban PFAS in all products, but means producers, supplier must actually assess safety and can be held liable if products are unsafe due to PFAS content. Just as a result, many PFAS, including some fluoropolymers, are currently outside the scope of proposed UK restrictions. So this is actually still ongoing, so I don't think it's finalized yet. Okay, going to the US, I want to be very brief on that one because we can have a separate webinar on this one. As you know, there are 50 independent states which I have actually different rules regarding the PFAS restriction proposal, but it's actually under the TSCA, where EPA finalized a rule requiring anyone who has manufactured or even including importing PFAS articles from year 2011 to 2022 should submit information reporting on the manufacture, use, disposal, byproducts, and other environmental and health effects of those PFAS. But what I understood is that this has been delayed already. Start of the submission has been delayed, and it's still not decided yet regarding the reporting, because there's also a delay to start of this submission period. Okay, just gonna move to Canada. Okay, Canada also has a reporting system for the PFAS class, which actually exclude fluoropolymers and all the focus on the products, PFAS-related substances, which are harmful to the human health and the environment. So these fluoropolymers are, however, under consideration in a separate assessment. So this already started 2025 and it's already ongoing. So these phases are subject to stakeholder consultation and timing may extend to the late 2020s as regulations are finalized. Okay, so this is actually the way of reporting. So you need to report 1 ppm of an article or 100 kilograms a year in a manufactured item. And if the products come in contact for children's in contact with mucosa, the inside of the body, or if it can be inhaled, dermal exposure, oral exposure, cookware, food packaging, all consumer products, clothing, footwear, furniture, or carpet, or any other product which actually simplify reporting. Okay, to finalize, continuous collaboration with other associations. As mentioned, we are in close contact with the Fluid Sealing Association, Plastics Europe, FPP for Europe, FPG, the manufacturer of fluoropolymers, European automotive, marine industry, IMechE, BVAA, Fuels for Europe, USGA, and so on. So our further steps are increasing the lobby. We are attending many physical meetings in Brussels, aiming for restriction option 2, or I would say, I would actually repeat myself to exempt for fluoropolymers and start preparation. We've already initiated, we've created an Excel template how to anticipate on the survey, which will take place in March, and where we have 60 days. We have already prepared a position statement paper, and we will also monitoring our members for alternatives. Oops. Thank you for your attention. I would like to stop sharing my screen and hand it over to our next speaker.
Okay. Thanks very much there, Sandy. It's very interesting how things are moving along. Sandy and Ralph will be available at the end to answer questions, but we're going to move on to the next presentation, which is Christian Gubert of he's also an IMechE member, if anyone knows that, European Hygienic Design Group. So let's go straight on with Christian.
Thank you. Yeah, I'm very happy. Thanks for being invited to share here in the case of Angst and Pfister and also IMechE. Yeah, I would just want to give you a short introduction to Angst and Pfister. We are not only a sealing trader, we also are now a sealing manufacturer and also a compounder of compounds. So really of polymeric rubber mixtures we use to produce several sealing products and other engineered products. And yeah, this goes the whole value chain from the polymer to the compound production at the end. Then we have high performance compounds to fulfill your needs. Your compound needs your article, which should fulfill different legislation, different demands, different performance behavior you have in your application. And PFAS, the regulation itself is also one specific one. And if we just now see here a couple of different compound bases, different rubber materials like EPDM, silicon, or HBr, and also these fluorinated, which are subject to the PFAS proposal now, we see that, the fluoropolymers, Danny just mentioned, to have an excellent performance, especially in the hot applications on the upper left corner, where the high range of temperatures are lying. And they also have a very good chemical behavior. And unfortunately, we do not have a different option if we have exactly that need. But there might be other options in the map of elastomers. But bear in mind, it's a very, very important part on the upper left corner, which has these fluorine in the polymer backbone and is giving exactly these performance you might need. So, but let's explore a little bit the rest of the map and just to complete the picture how we as a sealing manufacturer and member of the European Sealing Association are dealing with PFAS. Yeah? Well, one column of our 3 columns of PFAS strategy is the development of new compounds, new materials. But the other one is also to run together with ESA and others to run for fair and professional policies, because we really would like to have the fluoropolymers exempt from that proposal, because these can be produced, used, and disposed safely. This is just to make very clear. We are fully supporting this run from Sandy, but we also not only on that column, we also rely on 2 others, and one of them is the reformulation, the redevelopment of new fluoropolymer solutions, which do not have short chain perfluoroalkyl tensides, which was one of the major concerns regarding fluoropolymers. During that production, some spillage occurred, and they pollute also the environment. But this is something which happened in the past, like we maybe also saw that in the nuclear industry, that we first had something and then we realized that this is raising concerns. And so we run for fluoropolymers being exempt. We develop new fluoropolymers, and the third part, and that's what I want to talk to you now, is the development and the revisit of old materials which may have which might be used in some cases, might be a replacement in some cases where their properties, where their performance is just well enough, and fluoropolymers are not necessarily. And if we now look into one specific industry like the food or in the process industry, we have a couple of different demands to fulfill. The hygienic design, maybe, as I also speak for the European Hygienic Engineering Design Group, where there are a little bit of geometrical features we have to fulfill on the finalized sealing product. There might be other options, other things to consider, like the regulatory demands. But here, when we speak about PFAS, the major thing, the major concern is really the material resistance, which is at stake. It might be the product itself, it might be cleaning steps during production, might be, if we speak about food or pharmaceutical industry, sterilizing steps. There might be nasty ingredients, nasty for seals, nasty for sealing products like nuts and the resins and other products, if we really want to enjoy in our chocolate, but which are able to grind away seal. So even a chocolate cookie can be a very dangerous component for a seal. That's just to bear that in mind. And we looked into some of the applications of our customers, and we were able to replace some PFAS components, some PFAS FKM by an HNBR. By that way, we also checked the application of the customer carefully, and were able to present a solution which just is avoiding that the seal appear, which you see in the film now, can take off during some of these high pressure spraying and high pressure cleaning with hot water, and disposing the motor coils to water, destroying the motor basically. And by a new seal design and a new material, but not only the material itself, we were able to reinforce that sealing lip, and as it was possible to replace that FKM seal by an HNBR, we also solved the PFAS issue in that specific case. And this is just one example. There's another one where almost the same happened, and PFAS FKM was used and not necessarily was needed there, even if we speak about a very, very high demanding application, because this here is a chicken slaughtering machine. And this machine is able to kill 15,000 chickens an hour. And you can imagine what happens if one of these seals being used inside that machine is not working properly and causes that machine to stop. This is a really logistical nightmare. So these seals have to perform, but we were able, by a redevelopment of the design of the seal, to replace the used FKM by an HNBR. So this seal here is now safe. Therefore, however, this PFAS discussion, Sandy just presented to us how this discussion will end. It's made from an HNBR. And it does not necessarily need to be another HNBR. There are also other options here. In that case, it's a coffee machine. We're able to replace the PTFE part by ultra high molecular weight polyethylene UCOP, and with having a silicon core. So by just redesigning the seal, revisiting the challenge, which needs to be solved, the problem carefully examining, you are able to come up with new solutions. And this also might be a two-piece solution, like here with the UCOP with the springy inside by a silicon core. So also this solution is not containing any PFAS. And by the way, by revisiting these sealing solutions, we were able also to expand the service life from 10,000 to more than 40,000 brews. You can imagine this coffee machine now lasts much longer by just questioning the state of the current art, which might be subject to the PFAS discussion, and revisit that and maybe redesign it. So PFAS is also a chance. PFAS is also a need now to revisit old thinking, or revisit old solutions which might be just done differently in the past, but can be solved now by a new way. And one of these new ways might be the HNBR. We developed a couple of different PFAS-free solutions. You see here the EPDMs, some silicons, but I want to concentrate on this HMBR, which we are now also, to provide not only in the food industry. Here you see the pesto picture just as a reminder. HMBR was used in the past already quite some time, also in hop oils, but especially in these cases where abrasive media, nuts or other grains or other challenges were on the product side, and also there was a need for an oily or fatty environment. So the fat resistant and mechanical strong compound, that was exactly where HMBR was needed and used in many times. And in the past, some of these HMBRs were replaced and by such as we also did by FCAM materials. So maybe it's time to revisit that change, going back to an old compound which is developed according to the newest philosophy and the newest technology, and it's able and it's possible to really see here, new performance of seemingly old compounds, but also silicon and EPDM have a very good potential to be used in some cases, not in all, and that's very important to say. Also, these materials have their challenges. If we speak about the HMBR, we have normal standard procedures in the food and beverage industry, where I show you here some of these conditions. But it's very clear to say, in acids, nitric acid especially, HMBR needs to be carefully checked if it's possible to withstand. And it cannot be the same procedure, same process like an FCAM. That's not chemically possible. But anyway, I want to show you here on a comparison to our strongest competition. We were able to develop an excellent HMBR with very low mass and volume changes and also very low mechanical changes with these new compounds. And this was already doing in 5% of sodium hydroxide. SIP cleaning solution that's 80 degrees over 1 week. So that's 1 year of lifetime, basically what the seal will see during this service life, and it's performing better than our strongest competition. So we are very happy and very proud about that compound. And just to wrap up everything, so seals, sealing materials, like Sandy showed to you, they are not assessed truly, unfortunately, but they will be covered by the proposal. That's really, a pity. And I'm sorry, I do not have other alternatives with the same performance to you, also not to me, not also my colleagues or competition from the other sealing manufacturers. But the reason is very easy. It's a basic organic chemistry that the carbon-fluorine bond is the strongest we know, and we do not know a different page on the periodic system. It's also a little bit a pity that, these incineration studies, which were done in several areas, also in the Cultural Institute for Technology, were not recognized by the current PFAS proposal. So we also strive for a fair discussion in this topic, as fluoropolymers can be produced, used, and disposed safely. There were things done wrongly in the past, for sure. But this is something we all learn, unfortunately. So my option to you is basically you please try and change or consider to try and change to fluorine-free materials like the HMBR, the EPDM, or silicon I showed to you. They maybe have their performance which is just resistant enough for you, and maybe you did. You were opting for an FCAM and you never was in a really need for that. And on the other side, if you are in need of for FCAMs and the process demands it, and we sure know there are cases where this is, consider short-chain perfluoroalkyl substances free FCAMs produced with the newest technology, because these old FCAMs will soon die, will not be available anymore. They need to be exchanged to these sometimes called non-fluorosurfactant compounds. So with these points, I want to close. Many thanks for your attention. Happy to answer the questions after that. And yeah, thanks a lot.
Okay, thank you then, Christian. Thanks for your presentation. I'm sure if people have questions on this to follow at the end, don't forget to feed your questions into the Q&A section, where we will review them and ask the questions at the end. I think we're now moving on to Rob Grant, who's chair of the IMechE Water and Wastewater Division, is a specialist in this field, and I will hand you over to him. Thank you.
Thanks, Martin. Everybody hear me and see the slides okay?
I can.
Great stuff. Thank you. I shall plough on then. So, thanks everybody for coming along and having a bit of a listen. I'm Rob Grant, Senior Technical Director with Tetra Tech, as you can see from the slide there. I'm head of our design solutions team, and I have 30 years experience in water and wastewater treatment. I must stress I'm not a PFAS expert, so easy questions only, please. I'm a mechanical engineer though. I'm also not a product manufacturing expert either, but anyway, I'll tell you what I know, and hopefully it will be informative and interesting. So this is what I'm going to cover today: transmission routes into and out of the water cycle, treatment and removal possibilities for PFAS, the current regulatory framework that the water companies are currently working to, and just a few comments on recent developments that I've noted in the press and other sources. So I do know some PFAS experts, and they've shared with me a rather nice diagram here, just demonstrating how complex the water cycle can be in terms of interactions. As you can see there are lots of routes for PFAS to get into the water cycle, into our drinking water, and into and out of water and wastewater treatment plant as well. So just highlighting a few of those particular routes. Domestic drains. Obviously, residential properties have a discharge typically into the sewerage network. Industrial discharge, clearly higher potential for nasties to get into our system that way. Landfill leachate is an interesting one, leaching of PFAS from products in landfill, typically into aquifers, and then into the water cycle, but also runoff and directly into rivers and surface water systems. Surface water runoff, a wide number of different contaminant sources that can get into surface water network and then into our water cycle. Groundwater infiltration, again, either directly into aquifers or into the sewerage network. Obviously, infiltration into the sewerage network is often a major component of wastewater treatment plant influent. So what do we know? Numerous sources in various catchments of PFAS. These are typical PFAS-laden sources. Fire stations, firefighting foam, airports, mostly firefighting practice at airports, plastics in landfill, manufacturing and trade effluent discharges. Biosolids is an interesting one where the water industry is possibly a contributor as well as being a recipient of PFAS. We know water and wastewater treatment works accept water from various sources, and we also know that water and wastewater treatment plant does not remove all PFAS. In some cases, doesn't remove any PFAS. We also know that some conventional sewage treatment processes can make the PFAS situation worse, because it has been noted and observed that concentrations can be greater at different points in the treatment cycle. Particularly of interest is elevated concentrations noted in farmed catchments. So that's biosolids of any kind. So this all begs the question, are we removing PFAS from the environment, or are we just moving it around from place to place? So the clever people at Tetra Tech, my company, not me, have produced a PFAS app, which we're sharing and using with our clients to help them manage their risks This helps you to plot and understand sources of PFAS into the water cycle on a handy map there, with high, medium, and low risk sources being identified. And there, just on the slide, are some typical high, medium, and low risk sources that we've already mentioned. So, what can we do about it? Treatment and removal possibilities. Just depicted there in the slide is a typical treatment process, which is analogous just about for clean and wastewater treatment. So ideally, we would be removing PFAS at the source rather than through treatment, but this is difficult, as you've heard already through other speakers. PFAS enters water sources and the sewage network, as I've mentioned, via landfill and other historic installations, and removal can be very difficult. For example, in terms of firefighting, a PFAS source that's very prevalent already, it's already entered into the cycle through groundwater, etc. So removing or reducing is difficult. Identifying sources is also difficult given the sheer number that treatment plants get their influence from. And just a comment there to note that countries within the EU, which we're not a member of anymore, if you hadn't noticed, are moving towards a complete ban, essentially, of all PFAS, as you've already been hearing. This is intended to remove PFAS not only, of course, from the water cycle, but from elsewhere to decrease its overall impact. This is a big issue for the water industry, and bigger, I suspect, for other industries, as you've already been hearing. So, typical treatment stages within water treatment or sewage treatment are as described here. Primary, including settled sludge removal. Secondary, usually bacterial digestion of the organic content of the influent. As noted previously, this can make the PFAS situation worse. And tertiary treatment usually involves some kind of final settlement, filtration, straining, disinfection. So where can we take the PFAS out? Well, treatment technology is developing. GAC, granular activated carbon, ion exchange, and reverse osmosis, RO, or filtration, have all been shown to remove PFAS, and developments are ongoing in that regard because typically they're expensive processes. And sludge treatment is another field where developments are also ongoing. So sludge biosolids is of particular interest because PFAS is known to bind to sludge, making it, in theory, easier to remove. Conventional treatments include heat treatment, thermal conditioning, or indeed incineration, which is less popular these days than it used to be. Biological treatment includes anaerobic or aerobic digestion, and these processes all have different effects on PFAS. And it should be noted that PFAS can return to the water cycle through effluent discharge and biosolids leachate. So we are binding it into sludge, spreading it on the land, and before we know it, PFAS is back into the water cycle again. So what about regulations? Well, currently this is how PFAS is dealt with from a more general viewpoint. I won't go into this in too much detail, as I think Sandy's probably covered most of this already. But suffice to say that the UK government is taking this reasonably seriously. Again, I won't go into details here regarding the Stockholm Convention. I think Sandy's covered that. But of particular interest, of course, the water industry position. What's the impact of all this from how the water industry sees it? Well, in terms of effluent discharge, the environmental permitting regulations dictate all of this. There is nothing as it stands in respect of PFAS particularly, but there are some general regulations that protect the environment, where we're obliged to reduce harmful emissions, but nothing as it stands specific for PFAS. So in respect of drinking water, this is where it gets a little bit more interesting. Again, nothing statutory yet, but water companies are obliged through DWI guidance to risk assess their water sources and monitor their supplies. A low risk assessment of contamination, then no action is required, through to a high risk assessment, meaning the water company must take action. These risk assessments must consider catchment, for the raw water sources and the treatment process suitability removal of PFAS. And we do have guidance for upper limits for drinking water as depicted there in the picture. But again, these are, as it stands, guidelines, and nothing statutory is in place as yet. So potential future regulations, where might we go next? Almost inevitably, I suspect there will be tightening of discharge consent and more stringent and statutory drinking water regulations. There may be assessment and monitoring of influent and effluent at water treatment works and sewage treatment works, potentially biosolid and sludge management restrictions, possibly increased monitoring of catchments. Definitely, I think limiting and banning of certain products used within treatment. That's already happening, as you've learned from my colleagues in the sealing industry in particular. And the potential for investigations into microplastics, which can in some cases actually be added during water and wastewater treatment processes. So as I mentioned, just a few quick words on recent developments, things that I've seen in the press. A couple of things regarding removal of PFAS through new technologies, briefly mentioned, which could even be at the tap rather than at the water works, as depicted there in a picture. You may have heard the government has just launched a new plan to tackle forever chemicals, including PFAS. So the government is obviously taking it to some extent seriously. But there's also been some doubt cast recently on some studies which have shown PFAS to be harmful. I can hear all the manufacturers, sealing companies cheering. Although this may not be particularly good news for public health advocates, of course. Depends where you stand on that and where the evidence is taking us. But this slide is just intended to give you a bit of a flavour as to where we are at in the overall picture in respect of PFAS in the water industry. We don't know everything, and knowledge and solutions to the problem as it stands are developing all the time. And that's it from me. So thank you for listening. I'll hand you back to our chair, and we'll cover any questions and comments that have been raised in the chat and Q&A. Thank you.
Hi there. Thanks, Pamela. Have you got some questions from the chat?
There are some questions from the chat. I can go through them, Martin, but I thought you questions.
So I can't hear you very well. So should I handle that?
I can go through the questions if you like, Martin, but I thought you were going to do.
Okay, that's fine. That's fine. I'll do it. Well, the first question we got here, as Teflon is a material of construction in industry, are there any replacements yet for Teflon? Because that contains PFAS. Is there a replacement? That's, I suppose, one for Sandy and Ralph.
I'm happy to reply to that question. Thank you. Well, it all depends on the application. If it's within certain temperature, corrosive nature, there may be alternatives. As mentioned, if Teflon, so fluoropolymers or PTFE are being used for certain applications, then saying a one-to-one alternative is not yet available. If you want to have the same properties, the same durability, the low friction, but it all depends on the application. So if the applications is within range for other materials, then of course it could be used, but it all depends on the application. But if you ask me, is there a one-to-one alternative today for PTFE? I don't think I can reply that in a positive way.
Okay. Well, there you go. We still work to do. We have another question. Thanks very much. We have another question here, which probably is yours as well. But what is the safest way of disposal of IFFF foam? Which can, I mean, at the moment, if you can't, obviously, you put it onto a burning fire, it's not going to destroy it. So, incineration is an option.
However, firefighting foams are there to extinguish the fire. It can be destroyed by means of incineration. Having said that, you need to apply a temperature above 1100 degrees, which is not everywhere available in any incineration plant. So, but it can be done above between 1000 1100, but it needs to be a specific waste facility incineration plant. However, there are other methods. As I said, I'm not an expert in the recycling, but there seems to be ways of solidifying the firefighting foams. Yeah. So
Yeah.
this is extracting the aqueous, the water, the fluid from the product itself. And then there seems to be emerging technology like supercritical water oxidation. And so that's emerging technology to, let's say, get disposal of firefighting foams. But as mentioned in my presentation, firefighting foams are actually one of the initial causes for pollution into the ground, into the source, into the unfortunately drinking water. But there are ways, and these fortunately there are emerging technologies who actually try to remove the pollutants, and as also Rob mentioned, remove PFAS from our environment.
Yeah, just if I may just come in on the water aspect there. Historically, firefighting foam, when it's been in a controlled environment, i.e. used for practice, my understanding is it hasn't been particularly well contained or controlled, so it all ends up all over the ground and in the sewerage network, and
Absolutely.
just in the surface, in the ground and straight into aquifers. Now, there's not really a lot you can do about that problem. You can't go around remediating everything. It'd be very costly. In the future, and I don't know if there are any regulations in place now, but in the future there ought to be regulations in respect of containing firefighting foam when it's used in a controlled environment. Obviously, if you've got a fire in the public realm, there's not really a lot you can do to contain the firefighting foam in that instance. But where it's used for practice, particularly at airports, is a very good example. Containment is the key to reducing the problem, I think.
Okay, is a question from me to John Morton. John is involved with John Crane Seal Manufacturer. What are John Crane and other such seal manufacturers doing to reduce PFAS? So that, basically, I know you don't manufacture PFAS, but obviously you're big users. What is the effect of this on your industry?
Well, I think the effect is, as Sandy pointed out, there are no direct replacements. Where there are application-specific changes that can be made, i.e., using, as Rob said, going back to HMBR, for example, in certain applications. There are other technologies that you can use, non-elastomeric sealing, for example, that will allow you to have a seal that is that uses no elastomer at all. So you completely remove the elastom from the process, but that's can be very restrictive, and only have certain applications. So it's a big challenge, and it's something that's being looked at, I think, across the industry. I notice Luke is on there from AES. I'm sure they're in the same boat. They are doing, similar research, I'm sure, onto what alternatives are. Also, we're working quite closely with other suppliers, the elastomer producers, to come up with other solutions from that perspective. I think some of this will be driven from demand from industry as well. Obviously, the legislation is one thing, but the industry adoption and how that is looked at will also influence some of the the solutions that are found. But there are a lot of applications, as been pointed out, that you can't do it without some form of perfluoroelastomer type solution in there because of the chemical resistance needed, because of the temperature, and it's proving a headache.
Yeah. Is it true? I've heard a statement from someone saying that if we banned all PFAS from seal manufacture, then it would take the automotive car engines back to the 1930s. Is that true?
I can't answer that. I'm not involved in we're not involved in the automotive industry, but I can imagine that it will. Some of the process industries, absolutely. They have evolved and they are, they're what they are because of the material that is used in their processing. So if you take a key element away, and I think some of the electrification projects and things like that, you take a key element away, which is a PFAS based material, you're going to there's got to be some head scratching going on.
Yeah. Okay, thanks very much, then, John. Got another question here. A guy from Gavin Armitage says, we are a specialist lubricant company, use PTFE micro powder as a friction reducing additive. Clients are asking for PFAS-free statements. If we use micro powder, can we state the formulation is PFAS-free? I mean, sounds like not to me, but what's the opinion here?
It remains PTFE. It remains fluoropolymer. So but it's PFAS. As mentioned, fluoropolymers are different from the small chain non-polymers. So there's a big differentiation, and there's also a big misconception about, as explained, there are 10,000 different substances, and you have the non-polymers, the small chain, which are used in a lot of substances, a lot of liquids, the firefighting foams. But then you have the fluoropolymers or the perfluoroelastomers, which are a high weight, long chain molecule products, but unfortunately classified under the same PFAS regulation. So yeah, it's a bit different.
Yeah. So how would the exemptions work in the future? By industry, e.g. pharma, food, etc., or by part, e.g. pumps, valves, etc.? I mean, I guess this is still to be seen, what comes out of the EU, for example.
Exactly. Yeah, exactly.
Yeah.
We don't know what my perception right now is, as the 8 sectors, including the sealing applications, which are used in all industrial sectors, hasn't been assessed by SEAC, which means that SEAC will definitely not decide. So they will hand it over to the likes of the European Commission. So, and then the option is that they may actually send it back to ECHA, and or they can decide to exempt, as they do in Canada, to exempt fluoropolymers from the restriction proposal for the time being. Because, as mentioned, even if we have today, coming back to the first question, even if we have today a 1-to-1 alternative, it would take 5 to 20 years before it gets homologated. I had the privilege to attend some presentations by the automotive industry, but also the aerospace and defense. And of course, the regulations there are very, very strict. And as Martin already mentioned, if there would be a general ban, we would be launched back to the 2030s, because also for sustainable energy, for the new developing industries, for example, hydrogen and the proton exchange membranes, they rely on fluoropolymers. So it would have an influence on new technology, new energy.
Okay,
that's a very complex matter, and it's evolving, and we don't know where it's going. But I have the impression that there's also a change of mindset by the politicians, that they also understand that it would create a great risk for the economy. That's another topic, but it's been highlighted a few weeks ago.
In the UK, we've got our first Green Party politician, so maybe it's a downward step as far as we're concerned. Anyway, there you go. That's politics. Keep clear. There's a statement here, a statement rather than a question. Is the focus needs to be on the surfactants used within the polymerization process. This is one of the main sources of pollution related to PFAS. The finished articles, such as seals, etc., don't necessarily cause any issues themselves, as they won't break down or bioaccumulate, etc. Some polymer manufacturers are already addressing this with the use of fluoro-free surfactants, FKM, or closed-loop systems, FFKM. I think that was mentioned in the talk. I think you're correct. But what have you got any comments on that?
Well, about 50% of the manufacturers of fluoropolymers, they already use these non-fluorinated surfactants or polymerization aids. Having said that, it's still the end product is still a carbon fluorine radical, so it still remains a PFAS contained product. And even so, I read a document. So there are many studies, many documents around the OECD. They even say that some non-fluorinated polymerization aids may create a chemical reaction with the carbon fluorine radical. So yeah, there's still a lot of research to be done on the potential alternatives as well. Yeah. Do they provide the same performance and the durability long? So this is a lot of open questions, and I understand the downstream customers are asking these questions because they're uncertain about what's going to happen. Still a lot of unanswered questions, to be honest.
Is one maybe for Christian here, but this is another statement. It starts off as a statement. It says, this is a copy from the Q&A section. For some industries, parts are procured from the supply chain who are usually more aware of regulated substances and more liable to manufacture, provide suitable alternatives for PFAS. What can and must end users be aware of? How can they support the transition from PFAS applications to PFAS alternatives? I mean, in France, I'm living in France at the moment, and I go into the supermarkets and there's all these signs up, PFAS free this, PFAS free that. And this is mainly to do with frying pans and things like this. But I mean, I assume that's what the public need to look out for. What do you think, Christian?
I would say the industry would never be able to sell these PFAS-related products if we do not have benefit from that somehow, even as an end user. Yeah, I mean, if we speak about textiles, if we speak about all these textile carpets and things like that, where we also discuss these PFAS use. It's now a little bit sidetracked from the sealing market, but we enjoyed there the flame retardants. Not if we throw in a cigarette on the floor, that it will not start a fire directly. That was this is also these benefits which are even built part of building codes and fire prevention. So all these stuff was used, and as a former firefighter, volunteer firefighter, I can say these firefighting foams were rarely used in cases when you had really a large fire, mainly at airports and some other cases. So if you have a normal car fire, you would not likely use it anymore, or use safer alternatives which also exist now. But in former times, in the 60s, 70s, for sure this was used. But the end user here, I mean, just if we speak now as an end user to our suppliers, we should make them aware what are we really needing. If we say, hey, I want the endless lifetime, and I put in all these nasty conditions here, my supplier, my solution provider will always tend to have the highest resistance. The question is really, do I know what happens in my process? Do I, as an end user, I'm more likely to just ignore what's happening there and want to have a seal which is just working.
Just a comment. Yeah, I'm afraid I have to leave the meeting for another meeting.
Yeah.
I noticed there are a lot of other questions. I don't know if we can reply them in a separate way.
So thanks very much.
Yeah, I'm sorry about
Sandy.
this, but
No, I will. What I would suggest is that if we don't answer the questions today, and we're getting very, very close to calling it a day now, I will make note of them and get round to the speakers, ask them for their comments, which we'll then send off. But there's one question asked about the recording. Yes, this will be on the recording when it eventually gets through to the YouTube section. So I think we're going to have to call it a day as far as the questions are concerned. Thanks for everyone who's asked them.
Okay.
Sorry if your answer hasn't been gone through, but anyway, let's just get to the final closing slides. The first job is to thank the speakers. I think they're very, very useful, and I think it shows how important this solution is that most of the audience have stayed behind, which is very, very good. But anyway, so anyway, we've got some these are webinar recordings are on our YouTube channel. So if you want to take a note of these will obviously then also be on the YouTube if you get onto it. But basically, there's other ones on there. Okay, the next one, please, Pam. This is one that's coming. This is a seminar, and is it? Yeah, this is a seminar at Spirex Arco. You have the pleasure of listening to me for one of the talks, where I'll be talking about decarbonisation of the food industry. But that's I think there's a small cost involved there. I mean, I talk at a very small cost. So if you're interested and you live somewhere near Cheltenham or within travelling distance, come on down. Okay, the next one, please. Okay, so this is
I have to
our
go
contact
now.
details.
Sorry.
Okay, so we'll leave that up when we finally close. I will do my best to get these questions answered and out to the recipients, and would like to thank you very much for attending.
Thank you.
Okay. So, Pam, do you want to end the event?
Thank you. Have a nice
Thanks.
weekend.